Hello, AP Calculus folks. This is a video on tricky integrals. It's not necessarily got substitution. It's got a whole bunch of different things they throw at you to see if you understand what type of math you can do with integrals. And if you look at the first problem, this is a classic problem. It may not be given exactly like this, but they want to basically see, can you make a full-on substitution and not evaluate the integral, but just find the changed or simplified integral. A couple things. What they're doing in this problem is they are not only changing the integrand, the dx, but they are also changing the limits. And typically students forget all about changing the limits. So check out the different wrong answers in this problem when we go through it. They tell us what substitution makes. That was really nice of them, but don't think they're being nice. They're just setting you up. So here we have du equals 2dx. We are going to solve for dx, and that's going to be 1/2 du. We make our substitution. Don't change the limits yet. We have the root of u. Dx is equal to 1/2 du. So I'm going to put the half out in front because it's a multiplied constant. And this is du. And now let's change the limits of the integral. You get that from looking at the u substitution. They said let x be 0. So that's going to mean your lower limit is 1. Now you want to let 2 be the x value for the upper limit. So that would, you plug 2 in and you get 5. And now you would have your fully transformed integral. Notice they have exactly what we have here, but they have 0 and 2 as if you didn't change the answer. This is the wrong answer to make. They also have some other wrong answers, but I think the answer for this would be choice C. And that would be with the 1/2 out in front, we would have that. We would have the limits changed. We would have the right substitution on the inside and du at the end. So hopefully this helps. Here's another tricky one. Take a look at it, see if you can pick up on the trick. I'm going to pause the video and then we'll go over the answer. Okay. Well, what they're giving us is a function for f of x, so we should plug that into the integral. We have 3 to 5. For f of x, I'm going to put in g of x plus 7. Don't forget I've got another g of x there. dx. We're integrating from 3 to 5. We have 2g of x's plus 7 dx. Now, what do most people do at this point? They write this down too quickly because they're rushing through the test. They go 3 to 5. This is the wrong thing, by the way. This is absolutely the wrong thing. They say 2g of x, and then they do plus 7. They don't write their dx in, so then when they look at the answer, they're like, oh, okay, well, they bring the 2 out, and they right away fall for choice A, first one. And but what's happening is 7 is inside the integral. So that means you have two integrals. You have 3 to 5 of 2gx dx plus the integral from 3 to 5 of 7 dx. Now this area here has an area of 14. You can't forget about that because it's a function's height of 7, width of 2. So you've got an area of 14 there. So so choice B would be the better answer. And that would be the correct answer because you would have to integrate from 3 to 5, the area under 7, and that's what 14 is. If you look, you see a whole variety of different answers, but these are all answers for different typically made mistakes. Let's move on to the next one. The next one is a classic AP mistake. They're hoping that you look at this and you're going to try substitution and you're going to try all sorts of crazy things. But this one is where if you see you have a fraction with a single denominator, you can just modify that to just being 2 fractions. And then if you have this, from 1 to e squared, you can just now break the fractions and the integrals up. I have x squared, because that's what this is, from 1 to e squared dx, plus I have the integral of 1 over x from 1 to e squared dx. So now this one is going to be x cubed over 3, evaluated from e squared to 1. And then this one is the natural log, absolute value of x, evaluated from e squared to 1. Now, we have to just be careful about, this is very tricky, this problem, but you have to be careful because when you do x cubed, you've got, for the upper limit, you're going to have e to the 6th over 3 minus 1/3 plus, now for natural log, we have natural log of e squared, which is 2. And then we have natural log of 1, which a lot of people may forget that the ln of 1 is 0. So this is actually gone. So now we have e to the 6th over 3. So that works. We have e to the 6 over 3, e to the 6 over 3, e to the 6 over 3, and e to the 6 over 3. Okay, so they all work. So now we have to figure out what the rest of this is. So if we take these two and we put them together with our fractions, right, that's 6/6 minus 1/3, that's 5/3. So I'm going with choice B. Hopefully this has helped you, especially the most important thing. I think the most important thing here is that, when they give you a fraction that looks like that, instead of trying to do substitution, first try to break the fractions up. Even if they gave you x squared plus 1 over x to integrate, I mean, this can be substituted because the upper function it'd be a good substitution possibly, but I would first break up the fraction because that would just be way easier to deal with as opposed to working with anything more complicated. Looking at the next one is another classic problem they give you on integrals. People will spend time trying to figure out a substitution, but really for this problem, all you have to do is FOIL out the binomial. So instead of writing the integral as this, you would just FOIL it, and you'd have, remember, first outer and last, you have x to the 6th plus, remember how to FOIL. You don't want to say x to the 6th plus 1, because then you've fallen into the basic algebra 2 trap. You have x cubed plus 1 times x cubed plus 1. So we're going to have x to the 6th plus 2x cubed plus 1 dx. And then when we integrate it, we're going to get x to the 7th over 7 plus, now this should be all like old hat for you guys, 2x to the 4th over 4 plus x plus c if there's no constant, and simplify your fractions. And x to the 7th over 7, you got x to the 4th over 4, we have x, we have c, choice B is my answer. This is clearly a trap answer, trying to get you to do substitution. Hopefully this video has helped. I think we might have one more problem. To look at. Let's just see. Yes, it's another classic mistake. Try number 77, and then the video will be done. Promise. So we're back, and hopefully you had a chance to work on this. And they say that each region is 2 units in area. So what a lot of people will say, oh, this is simple. Well, this is just going to be from 3 to 3 under f of x and plus 1 dx. So what people will do is they'll say we have -2 area, we have +2, we have -2. So the area from the integral is -2, and they're going to do +1, and they're going to get -1, which is a trap answer. So that's not the answer. You have to break this up into 2 integrals. You have to break it up from -3 to 3 under f of x dx, plus the integral from -3 to 3 of 1 under dx. I mean, not under dx, but we basically find the area of a 1 function, which looks like this, and you're finding the area from -3 to 3, and the trapped area is equal to 6. So this will be 6, and this part will be -2, so here is your answer. Now, the reason why they're doing this to us is because they want to see, do we understand what the dx really means? The dx shuts off the integral. It's the end of of the function that we're finding area under. So make sure that whatever is before the dx, that is considered to be what you're integrating. And it's just a little review. Most of us know this already, but we wanted to make sure that you guys still remember that and don't fall into some of these traps. Hopefully this video has helped you with some of the AP Calculus traps, and I look forward to hearing your comments. Thank you.